Hello everyone and welcome. Hi Eric.
Hello, how you doing today, Alex?
Yeah, that's a great day, that's a day of a big release for us, so I feel a bit tired but very happy. And you?
I'm in the same boat. I'm very, very tired. It's a long road getting here, but we're here. It's great.
Yeah.
Wonderful.
So, if you can hear us, if you can see us, please set the thumbs up in the YouTube chat and let's celebrate together because that's a special day for all the Apache Cassandra community and DataStax, of course, as well.
Yes. All right. And it looks like we got Cedric's giving us a thumbs up.
Okay. So that's already
You're
great.
helping us. That doesn't count.
No, but I mean, Cedric today is also not only an answerer but a listener. Thank you, Sharaf. Thank you, Babu, and all the other people today with us. And that means what we can start.
Yes.
Okay. So, but Eric, what makes these days so special for us?
There is a new open source project in town, and it's something you and I have had our hands on for a little while now, but we are actually bringing it public. I think the GitHub repos all went public, the Jira went public all this morning, so we are going to be talking a little bit about that, what it is, what it looks like, why it's cool, and how you can get involved. Again, it's open source, so not a DataStax only product. It's not like DSE, DataStax Enterprise, or anything like that. This is an open source project with other open source tools that are around the Cassandra community built in, and we'll get into what that looks like as we progress here throughout the day.
Yeah, and Manil is perfectly right because today is the official public release of K8ssandra. We discussed it a lot before what the Cassandra is, and we talked about Kubernetes as well, and today is the public release for K8ssandra, Cassandra with all the required ecosystem for operations built in together into the something you can easily run on Kubernetes with just a couple of commands, and that's really easy to use, and you will see that today.
Yes. And the cool thing is, so this is the second time we're actually doing this workshop. Shh, don't tell anyone. But if you were here for yesterday's KubeCon workshop, you got a sneak peek and you got to see a little bit. This is a lot of the content today is going to be the same, but feel free to stick around and ask questions and add color where you can. So,
yeah, absolutely. So, what I think we can start already. That's a very good time to start, and let's take a look about the things we are going to do today. So we have to ask you some questions and prepare for the workshop. We will cover Cassandra and Kubernetes Basics, but basics. You see, we are speaking about running Cassandra and Kubernetes, so if you have no idea of both Cassandra and Kubernetes, this workshop isn't going to be easy for you. But we will not take a too deep dive, don't worry. Then we will discuss about how do you set up and monitor K8ssandra, work with data, scale the cluster up and down because, well, Cassandra is the easiest database for scaling in both directions. We will do some anti-entropy fighting with repairs and we will switch to resources that may help you. And we will use 4 different tools to cover during these workshops. For the streams, we are doing the main stream now in YouTube and we have a backup stream in Twitch. For the questions, you can use YouTube chat, but the main place for us is our Discord server, which is going to be much better. And to do the steps, that's a workshop, so you are going to do your part of the work. You can use your machine as long as it supports Docker and has some firepower. But if it doesn't work to you, you can use our Linux box in the cloud delivered by AWS, thanks. And materials are all completely available on GitHub. I kindly ask, we have link in the description of the video. Now, about the practical steps. You have two pills to decide which one to take: your laptop or cloud environment. So if you do it on your own, you will need Docker and Kubernetes as a kind or Minikube, for example. Minikube should work also as well, as far as I know. And if you cannot have Docker, or your laptop is not so strong enough to run the whole system, you may use our cloud infrastructure. So if you want to grab our cloud instance, please contact jack.fryer@datastax.com, and I see Jack in the chat already, so you can write him an email and he will immediately send you back the... Yeah, thank you, Jack. If you need a cloud instance, please send us the things, send the things to Jack. And this one is completely prepared, so it has Kubernetes installed with kind, and that's a CentOS machine.
Yeah, I would just throw out there that our infrastructure is going to be much easier. It's a much cleaner experience for you to hear today, because we're not really going to allow time for you to set up all the Docker, the kind cluster, and all that that stuff. It's not built into the labs here. So highly recommend you go with our infrastructure. If that's not an option for you, we do have in the GitHub today, we'll have instructions to how to set it up yourself. But we do try to provide everything so you can get the labs done.
Yeah, absolutely. Thank you, Eric. You are very right. For a smoother experience, we recommend to use cloud infra.
All right.
And I have the question in the chat. Do you recommend any specific course for the certification, or one listed on Cassandra Academy is sufficient? I recommend learning path at the Cassandra Academy. Yes. Academy.datastax.com. We have learning path for admins and learning path for developers.
Yeah, and it's a full curated thing. So all you got to do is click there, and it will actually line up the correct courses for you. I think all of them take Intro to Cassandra, and then it kind of branches off a little bit from there. But they both go very in depth on the content. And you should be able to pass. If you do the exercises, you do the learning paths, and you really absorb the stuff, you should be able to pass the exams without too much trouble at all. So
good. Now, request your cloud instance if you are going to do practical steps with us, but not following this link, but contacting jack.fryer@datastax.com. His email I've just pasted into the chat. And that would be enough for us to start. And we are going to cover Cassandra and Kubernetes Basics. That's what we need to discuss. So, Apache Cassandra, very quickly, Apache Cassandra in 5 minutes. Apache Cassandra.
I'll hold you to that.
Oh yeah, that's going to be something special.
Now.
Ladies and gentlemen, start your engines. So, Apache Cassandra is a NoSQL decentralized distributed database. And that's not every word in this phrase is very important, because it is NoSQL distributed decentralized. So we use it to store data as you do with PostgreSQL or MySQL or in other databases, but it works in a very different manner. It's different to our databases. So first of all, it's decentralized. There are no things like primary or secondary nodes, or like we use it to say master or slave nodes. That's no things like that. Every node has the same duties. Then it's distributed. So we are going to work with multiple nodes at once. We are not putting all our eggs into the single basket, but we are spreading data and spreading responsibilities over multiple nodes. And that's what allows us to handle any kind of problems, and we can grow over the size of a normal database significantly. Who knows what's the biggest Cassandra deployment in the world? I will not stop for too long of that, but we know what biggest Cassandra users, not only users but also committers, are Netflix and Instagram and out. Oh no, Oliver, 10,000, much higher. The biggest known personally discussed by me deployment was done by Apple, it was 160,000 nodes. Once again, I like how it sounds. 160,000 nodes, Apple. And now we have heard what some Chinese companies like Huawei have even more. Yeah, Netflix, Apple, Instagram, and some others.
Spotify is another big one.
Spotify,
almost all of their infrastructure, their data layer is Cassandra, from what I know.
Yep, exactly. And that's a non-relational database, so no SQL database. Nodes are organized in the data centers or rings, but every node communicates with every node. So there is no things like primary node giving orders to secondary nodes. It doesn't work like that. What are the main features of Cassandra we want to cover? Cassandra is distributed. So we have a lot of nodes working together in a cluster. It makes it responsive and scalable. We can always add more nodes to have a higher throughput or volume or whatever we want to have. And it's replicated. It means what your record, your data is replicated to multiple nodes, and even if one of those nodes is not available, your data will be returned by other nodes, so you can do write and read operations even if some nodes are on fire. And as said, there is no single point of failure because we have a true democracy here. There are no primaries and secondaries. There are every node is the full-size citizen of the whole cluster, and they have the same duties. They are absolutely equal. Cassandra is distributed and highly available. Nodes are organized into the groups, data centers. Nodes monitor each other's health status using a gossip protocol. Cassandra routes requests away from nodes that are down or slow automatically, and that's not for your operations guys or girls to take care of. That's not the question, that's what Cassandra takes care of. Cassandra scales very good, and we speak not about vertical scaling, traditional for the databases. When you are out of power, you want to have something more, you buy a new bigger server, migrate your data, and remove the old one. That's vertical scaling, buying more and more powerful hardware. We prefer another way. We prefer to go with horizontal scaling. And that's a very different way. The problem of a vertical scaling, first, it gets expensive very soon, but also second, as soon as you still have the same issue. That's one single instance which has one single power of source of electricity, for example, with all the problems related to that. And problem for us here, with horizontal scaling, we can do it in a different way. We prefer to add more nodes. And one of the best features of Cassandra, it scales not only horizontally, but also linearly. It means what we have very low to zero overhead on adding new nodes. And every time you add next node, your cluster is getting more and more powerful from the volume point of view or from the throughput point of view. You are slow, check your data model and add more nodes. You need more capacity, add more nodes. And that's how it works. This picture on the right side, we don't want to show what Cassandra is faster than our databases. Well, it is, but that's not the point for now.
Yes.
Yeah. You know what? On the different testing infrastructures and with access to the settings and configuration, I can set up every database to be quick or slow. What I want to set here, I want to highlight what every next node added, it scales linearly, so we have no overhead and we have more and more power growing over time. If you know, maybe Netflix, kind of tiny company streaming some not so popular TV series, maybe, they did a great research. It's published in their tech blog. They scaled Cassandra cluster from 30 nodes, I believe, to 300 something, like 350 maybe. And what way they're testing how output and volume grows, and it grows linearly. So that's not only my words, that's Netflix words. What are the main principles for Cassandra? First of all, everything is distributed. Data is distributed over clusters. Those orange circles on the left side are servers, and the table on the right side is the table. Now, when we have those 7 nodes and this table on the right, how do you think data will be spread over? So which node stores which part of data? We can say it's going to be stored like that. So every node is responsible for a part of a table. At this point, you may ask why. I'm working with my Postgre or whatever relational database you are using, and it doesn't think like that. Will it be convenient to use? Answer is very simple. Take a look. Cassandra is big data ready. Your relational database may work great till some limit. And after this limit, it doesn't work great. And after some more, it doesn't work at all. Why? Because it was not designed to be big data ready as a design concept. As a result, it works good as long as it's in the conditions it was designed for. So some limited amounts of data. Maybe gigabytes of data, maybe some terabytes, but not more. And when we start to speak about dozens terabytes or dozens petabytes like Apple works, then you need something like Cassandra. Cassandra separates data to multiple partitions. It's called partitioning, based on the partition key you design. And then if we need more volume, we simply add more nodes and the partitions will be moved over the cluster again. Very simple. Then what is a partition key? Partition key is the column in your table you are using to identify the partitions. Like take a look here, we have Toronto, Paris, Berlin, Mumbai, Berlin, Moscow, and so on. How they will be stored? Based on your partition key. In this case, we use the partition key, we use city as the partition key. So data is grouped together, and that's how it works. That's not only data is distributed, but data is replicated. Compare those 2 slides. This one and that one. In short answer, every replica, every partition is duplicated for a very simple high availability reason. When you can configure your Cassandra to work like that with replication factor 1. It's good for your laptop, it's good for your maybe test environment, but it's bad for your staging and that's bad for your production. When you raise the replication factor to 2, it looks like that. But what we recommend to have is replication factor 3. Replication factor 3 is important, so you can afford losing a node while still being consistent. People call Cassandra eventually consistent, but that's not perfectly correct because Cassandra is configurably consistent. And you can move this switch to any site you prefer to have right now. So every data is replicated to be on multiple times available. And finally, replicated, distributed, what's next? Distributed globally. It means what with Cassandra, you can easily have data centers all over the world working as a single cluster. So your data is on the United States East, and then Europe Central 1, and then Asia Central 2, and they are all working together handling the same data. Why? Because you want your data to be close to your clients. If you have clients everywhere, you want your data to be also everywhere. It's easy to run application into any part of the world as long as you have data center there, but with data it's usually not so easy. With Cassandra it's easy. And finally, Cassandra is absolutely platform agnostic. So you can run exactly the same cluster, different parts of a cluster, different data centers on rings, in the Google Compute Platform, Microsoft Azure, AWS, on your own data center on premises, on absolutely the same time, and it will be still the same cluster. Cassandra is platform agnostic. You can run it everywhere, and they still will be fully operational working together. And last point of that, so the use cases. Scalability. Everything what relates to high throughput, high volume, a lot of writes, a lot of reads. That's very sounds like Cassandra use case, especially when it changes. Today you have one number of requests, and tomorrow going to be Black Friday, and you are going to have 2 times more. No need to buy more powerful server. Just add one more node, wait till Black Friday is over, decommission this node, and you are great. You are highly available all the time, and your expenses are very well optimized. Okay then, availability. Everything what relates to mission critical systems. Never data loss, always available. That's absolutely about Apache Cassandra. When distributed, whatever we mean about the global presence, that's a perfect use case for the Cassandra. Whatever we speak about the compliance or GDPR, if you want to have some of your data available only in Europe and some other parts of your data in both Europe and the United States, you can easily do that, specifying different replication factors for different data centers. Like I'm located in Germany and there are some GDPR rules, and you can, for example, store in some cases data of German clients only in Germany. No problems, you specify replication factor, allow it for the data center in Germany, and remove that for this kind of data for all the other data centers. Boom, you have your data only in Germany. And then all what goes to cloud native modern applications. Microservices, very good fit. Cloud native and cloud deployed, very good fit. Kubernetes, perfect fit. That's what this workshop about.
All right, Alex, you said you'd get it done in 5 minutes. You want to know what your time was?
Yeah, so what that?
Let's see if we can see it on screen here. 13 minutes and 41 seconds.
Oh my god. You know what? I would better speak about that for days. So it's always very hard to fit into the smaller size. I will try to improve. Thank you, Eric. Good. So, Kubernetes. We have some people with pretty low experience on this field, but we will not do a deep dive. In general, the main idea what you have to understand, Kubernetes is an open source system for management of containerized applications. And that's what it does. It helps you to deploy, upgrade, remove, scale containerized applications. So what does that mean? Before that's kind of famous picture I see literally on every conference regularly. Virtual machines, old approach to virtualization. Well, not old, but different, I would say. Older approach, which helps you to have higher isolation using guest operating systems running on the hypervisor or host operating system. It works very well. It provides a very high level of isolation, but also brings a problem. A lot of your resources consumed by guest operating system. That sometimes may be good if that's your intention, but you know what's the funniest point about the operating systems? Really, no one needs operating system. You have operating system on your laptop. You don't need that. You want to watch kitten photos on the internet and funny videos and learn things at the DataStax developer workshops. So basically you use browser most of the time and maybe your integrated development environment, but what's the operating system then? It's just the glue what brings this software together with your hardware, allowing them to work together. But per se, operating system is not the thing you need. You need to do something different. And containers is a new approach to virtualization, which allow you to do this thing easier. In the containers, processes or applications you are running are being executed directly on the host operating system without guests operating systems. So that makes things little bit less isolated maybe in some cases, but much more lightweight. So containers usually much more lightweight than virtual machine images, and that makes them much more convenient to use. But the containers, just as they are, like Docker containers, for example, they are great, but you still have to work with every particular image and every particular container. And you have to say Docker run, Docker stop, and many other operations. And then you are trying to do some more or less complex application. Even for simple applications, I believe some of you were at my 4 weeks Docker learning path. I hope if you did, please write about that in chat, so I know there are some people from my Docker learning path. You remember the week 2 when we tried to run pretty simple application without any orchestration, without Docker Compose, without Docker Swarm, without Kubernetes. It was pretty a lot of things to do just with Docker. So we consider Kubernetes as an advanced Docker Compose. I hope no one will kill me for this comparison, because
I was gonna say, I can see the pitchforks coming out already.
Yeah. So you see, the general idea is the same to orchestrate, but of course Kubernetes works on much bigger scale. When you need something on your own laptop, you go for Docker Compose because it's easier than Kubernetes. But when you are going to run over a big data center, or maybe many of them, and complex applications and hundreds of services, you definitely need Kubernetes. So what Kubernetes does? It helps you to orchestrate the storage. It helps you to manage configuration and secrets. It helps you with automated rollouts and rollbacks if needed. It helps with service discovery and load balancing. Horizontal scaling, running multiple pods, for example. It cares of a self-healing if some pods are broken, and many other things. What's the infrastructure? Very simple. When we speak about the base Kubernetes infrastructure, you have to think about the following things: master nodes and worker nodes. So, Kubernetes cluster consists of a control plane running on the master node, and free worker, not free, well, as much as you want to have, worker machines. They are usually much more powerful because worker machines are the nodes where you're going to run your applications. And Kubernetes control plane organizes communication of these machines, takes care of networking, scheduling pods, and so on and so forth. So there is pretty a lot of information. I don't want to do a deep dive. But what we have to do, what we have to know, control plane consists of an API server. So that's something what answers your queries. I want to scale up, I want to scale down. That's what you ask a Kubernetes API to do with API server. Controller manager helps you with everything what relates to operations on the Kubernetes. Scheduler cates of the pod's placement. I'm to explain pod in a moment. And etcd is the, we can say it's a database for Kubernetes. Well, not only for Kubernetes, but used by Kubernetes in this case. So, and on the worker node, we have something already more interesting. So, kubeproxy, Kubernetes networking is a long story. There is a set of software-defined networks working together, and kubeproxy is the service responsible for the networking things. And now pod. Pod is a very important idea. When we work with pure Docker, what's the minimal unit of access for us? It's a container. And in Kubernetes is a little bit different because every pod. So basically pod is just a container for a container, very simple. You can ask like, why do we need the pod? We have containers already. Why don't we use just containers? Answer is, first of all, Kubernetes doesn't work only with containers. It can be a special kind of a virtual machines. It can be RKT containers, not Docker containers, and so on and so forth. So for the unification, we use pod, and pod contains something which is usually Docker container, usually, but not necessary. Then
way to make it kind of agnostic too. It creates, it doesn't care what you have in that pod. The pod is going to be able to communicate with the other pods, and all of that is kind of abstracted away, where you just don't have to deal with it anymore.
Exactly. And one more thing, one container is a one single container. With pod, it's a little bit different, because in pod you may have multiple containers of a different kind at once. What does that give us? In some situations, your containers work so close together, so they need to share something. For example, inter-process communication is not directly possible between different pods, but possible for containers within single pod. And some other options. If you want to think, if you want to have one container per pod, if you want to have pod A and pod B, or you want to have your container A and B in a single pod, think on how do you want to scale them. If your containers always scale together, then they make a good pod. For example, when we run Cassandra in Kubernetes, we have 2 containers per Cassandra pod. One is the Cassandra as it is, and second is a Cassandra sidecar, a special application to help with management and metrics of a Cassandra for monitoring. And we always scale them together, so they make a good pod together. But for most of the cases, you will see one pod means one container. When ecosystem for the Kubernetes may be really overwhelming, because Kubernetes was originally designed by Google to solve Google size problems. And that all it comes from. But don't worry, you don't have to know all of that. I guess there are no one to learn all of that. And again, we speak mostly about the developer things today. So for us, it's going to be much easier. And
very simple.
Very simple. And he comes K8ssandra. Yay. So, yeah. Eric?
Yeah, so K8ssandra is basically taking all of the complexity of the distributed systems in working it all together, weaving both Kubernetes and Cassandra together into something that is actually very, very simple to use and install. So, in the past, everyone knows that Cassandra is a distributed system. Distributed systems are hard. Kubernetes is a distributed system. Distributed systems are hard. And you try to put 2 of them together, and it's just a ton of work. That's been a kind of a historical thorn in the side of both Kubernetes and Cassandra, is integrating these 2 things. So what we did with the K8ssandra project, again, not just DataStax, this is an open source project. We went and we basically used some tools that we'll get into to integrate the 2, tie them closely together, so that instead of having to spend weeks, hours, sometimes months getting all of these components working adequately for production, now suddenly we can do it very, very quickly. And we'll actually do that within the session here today. It's, I think, about the last hour of the session, we're going to go through not just set it up, but we're going to do a number of operations with it as well.
Yep, exactly. Okay, sorry. And yes. Oh, that's correct. That's correct. That's correct. First quiz of the day. First quiz of the day. So warm up your hands. Prepare for the quiz. Yeah, I'm switching to Menti. And that's the quiz time. So set the thumbs up. I'll know you are here. And that's going to be Cassandra Fundamentals. I know we have some people with experience today. That's something very interesting for us to see. But please give some chances to novices as well. So once again, Menti.com, use the code 624050540, I'm sorry. And I know we have code in the chat. Okay, so I think we are good to go. Jump in right now, otherwise you will not have time to answer the first question, and as a result you will have worse results. I see we have almost 100 of people in this live stream, so I really want to have more people than we are having right now. Make me 45, okay?
And the top 3 people on this quiz get a prize. So there's this one, and then you'll have one more opportunity.
Yeah, and people ask all the time, do you send prizes to my place? It's like a remote one. We don't care. We deliver worldwide, as Cassandra does. Nice. Good. So 43 people, 2 more, and we start. Good. 44, one last, 45. Here we go.
Let's do it.
So, answer fast to get more points. What is a partition key? A consecutive number applied to each new record. A designated field in your table to partition your data. An optional table field for optional partitioning. Another word for a garage key. And we are done. Time is up, and most of you have answered correctly. It's a designated field in your table to partition your data. There is no things like consecutive numbers, because when you have a distributed system, you will have to agree on the consecutive number over multiple nodes in a hostile network environment. That's not going to work in a fast way, and that's not an optional field, that's a required field.
Yes.
So, who was the fastest today? Carl Gustav gets the first place with 944 points, and very close to him, Ashley and the Hustler. So, but that was only the first question. So let's take a look what's going on to happen next. And that's the question 2. So answer fast to get more points. What is a partition? The smallest unit of data distribution, a group of rows. A replica node in a Cassandra cluster. A geolocated grouping of nodes. A dividing wall. What would you pick, Eric?
I'm going to go with option 4, a dividing wall.
Yeah, I mean, everyone knows it's a dividing wall, that's clear.
Right.
But you know what? It looks like they don't agree. Answer is this. Smallest unit of data distribution and group of rows, and that's the correct answer. And no, partition is not a replica node. And I want to see the changes. So it looks like we have some... Oh, and Carl Gustav was fastest again. That's a good score today. Wow. Yeah, and we have Sudhakar on the second place, and Ananya Gupta is on the third one. And Ravikiran Reddy is so close with 5 points difference to the third place. That's a very good result. Yeah. So that's a question 3, and we are getting close to the middle of the first quiz. And answer fast to get more points. What is the recommended replication factor? 3 per node, 3 per cluster, 3 per data center, 0. We don't like replication. So this one is a little bit trickier for Cassandra novices, but well, that's pretty fair.
Yeah, it was mentioned very briefly there.
Yep. Ooh. Oh, that's painful.
Bet you this is going to switch up the scoreboard.
Yeah, that will change the scoreboard. So correct answer is 3 per data center, because if you have 3 replica nodes per cluster, that isn't going to work in the quick and fast manner and reliable manner for you, and definitely not 3 per node. So recommended replication factor is 3 per data center. In some cases, maybe 5. And okay, hi Skivus, I see some familiar names already. And Sudhakar was the fastest one, but it was not enough to get to the first place. And we have Suresh, Sudhakar, and Ananya Gupta on the first 3 places, and Charles are very close to the first 3, but not yet in. So let me see. And that's a question 4, and I want to see your answers, because we are getting close to the end. What happens when a node goes down? You lose data. Coordinator stores a hint over replicas served for request. There is downtime for the nodes to rebalance. Eric's option, node never goes down.
Yeah, I mean, that's if you build the system perfectly, they will never fail, right?
Yeah, that would be great, but the correct answer is coordinator stores a hint and other replicas serve the request. And that's the correct. There is no downtime for the nodes to rebalance. No, there is no downtime. Please, see that the people with relational databases experience. They believe in downtime. In Cassandra team, we don't believe in downtime. If you do everything correct, you can go for the full uptime. And yeah, so there is no downtime if a node goes down. And you lose the data is also wrong because there are still replica nodes keeping your data. So, what are the changes in the leaderboard after all? I see. Very well. So, Suresh was fastest again, and Sudhakar and Ananya still holding the top 3 places. Very well.
All right.
Question 5, and we are getting close to the end. How many master nodes should be in each cluster? 1 master node per 3 replica nodes. 1 master node per 2 master nodes per data center, 1 cluster master with at least 2 data center submasters. 0, we don't use master nodes. And the time is up, and the correct answer was 0, we do not use master nodes. And when I say we do not use master nodes, that means exactly what it means. No master nodes in a cluster. And therefore, any other answers are wrong.
Yeah, we were getting a little tricky with that one too.
So it looks like we made them think. Take a look. Yeah, and Sudhakar was the fastest one this time getting to the first place, but the top 3 list still looks the same. But there are some people like Charles, KV, and Agent X9 who also going to fight for the top score today.
Definitely could switch it up here. More question, right?
So, last question. So, don't make a mistake right now. Answer fast to get more points. Is active-active replication possible for multiple data centers? Yes, within the same geolocation. Yes, if a replication is coordinated by a cluster primary node. Yes, Cassandra is natively active-active. You cannot have multiple data centers.
Now, if you're paying attention to the last question, that should eliminate one of the answers here.
Yeah. So it was easy this time. Cassandra is natively active worldwide, globally. So there is no thing like replication coordination by a cluster primary node because there are no primary nodes. And that's not about the same geolocation. That's completely possible all across the world. So we can now take a final look at the leaderboard. And are there any changes? So none of the winners made a mistake, but will be the changes because of the points. Yes! On the very last question, Charles jumps into the top 3. So Sudhakar with 5,580 points gets the first place. Very well deserved. Suresh get to the second one with a very small gap to the first place, and Charles jumps in with a very, very last moment. Very great job. And Ananya Gupta, I'm very sorry, but Charles was faster.
So for the top 3 of you, make sure you take a screenshot of your win and send that to Jack Fryer at DataStax.com. He's posted in the chats there the address. Just send it there and he will get you sorted out with your prizes.
Yep. So make a screenshot, don't forget, and send it to Jack Fryer. He is exactly in the YouTube chat right now. And if you didn't make it to be in top 3 this time, don't worry too much, because you know what? What's the priceless price of this workshop? It's not the gifts from DataStax, although they're great, but your knowledge, your skills, and your higher salary as you are doing your job better and better. That's what really values.
I think we all like higher salaries, right?
Yeah, I mean...
Is our boss listening?
Yeah. I hope so. I've seen Patrick in the chat. Good. Okay. So... Well then, we have now advancing to K8ssandra. And I bet I'm switching now to Eric. That's
awesome.
That's going to
wonderful.
Be your turn.
Well, I get to do kind of the coolest part of this presentation, but it's also the most dangerous.
I mean, that's a correct time to say, sorry, Alex, I'm going to do the coolest part of this presentation.
Right.
Yes, okay.
All right, so we've talked about
wait a second.
Kubernetes plus Cassandra.
Wait a second, let me switch to you, please. Boom.
Absolutely.
So, okay, here we go.
All right. So in the last hour here, we talked about Cassandra and Kubernetes, and we talked about kind of how they operate, what they are, what they do. Now we're going to talk about putting them together. And fortunately for you all, we're not going to have to put them together ourselves. That's already been done for us. We're just going to get to consume and use that. So pre-work for today. Hope you all got the message. We got to do some network setup, network storage, firewall setup. We got to install a bunch of nodes, which is going to be downloading some TARs and getting those configured as services. Install our Prometheus Grafana user agents. Some there's just a lot here. We got to. Okay, no, I'm just kidding. We don't have to do any of that. That's all done for us.
Liar.
Yes, I know. I couldn't help myself. We actually get to do some very simple stuff. So all you need for today is either the cloud instance, or you could have set it up on your own following our documentation. You need to be willing to learn, and having a pulse is also a very good thing. Of course, for our undead friends, we're accepting of them as well. All right. So K8ssandra, what is it? Simply put, it's Helm plus all the things you would normally need to run and manage your Cassandra cluster, all bundled up into one. Helm is basically a package management tool for Cassandra. Sorry, not for Cassandra. Goodness, oof, that's a big oof. It's for a package management and templating tool for Kubernetes, and it allows us to do a lot of really dynamic things that wouldn't be possible otherwise with our Kubernetes deployments. We'll get into that. We'll actually start messing with stuff like resizing things on the fly without editing YAMLs. So really, really cool stuff. All right. Setting up K8ssandra is actually very easy. Now, today we're going to be using release candidate. This is, as we mentioned this morning, the project went live this morning. So this is the first release or candidate that we have for K8ssandra. It's still very much a beta product or a beta tool. I'm not even going to call it a product because it's not a product. It's open source. It's a beta tool, but the intention with this project is to take it to something that will be used in production across the globe. Basically, anywhere you have Cassandra and Kubernetes together, you can just use K8ssandra and it will work. So a couple things here today. With Helm, if you've ever used apt or yum as package managers on Linux, Helm works very similarly. We actually add our repositories just like we would on any of those other tools, but then we also get some additional templating capabilities, which are really, really awesome. So you see there we have on the slide the Helm repo add, and then we add our repo, and then we update our repo, which basically just says, okay, we added something, now you make it go active. And then we actually do just a Helm install, just like you do an apt install or a yum install, and then we just install K8ssandra. So really, really, really cool. Does a lot of just awesome stuff that we would have had to take hours to do before in basically a single line. Now, I will point out that for today, if you're watching this, sometime in the future on YouTube, all of those set flags, the set ingress, you probably aren't going to need to run those because that's all going to be worked into the actual Helm install itself. But what that basically is doing here for us today is it's setting up an ingress. An ingress is a way to communicate from the outside into a Kubernetes cluster, so we can actually get at the UIs that we're going to be dealing with, and the various pieces of this that we're going to be playing with today. So normally you won't need that, but just since it is a release candidate, early release, we are going to have to do that ourselves instead of it being handled for us. All right, with that, let's get into it. So that is all of that's required to set up our Cassandra. We're going to also get Cassandra Reaper and Cassandra Medusa. Now, Cassandra Reaper is basically a tool to handle anti-entropy repairs in Cassandra. Anti-entropy repairs we'll get into a little bit more, but for now, just understand in a distributed system, the laws of physics still apply. We still have to deal with entropy, things being corrupted, things getting out of sync, things generally tend towards chaos. And so repairs help to bring things back into sync. We also have Cassandra Medusa, which is not 100% implemented today. It is like 95% of the way there. We're not going to get hands-on with it, but it's there and you can play with it. And it is also, I believe, in the docs currently on the K8ssandra.io page if you wanted to read about it and maybe try it out yourself. It is a backup tool. It is for backup and restore, and it basically handles all of the needs you'd have around, taking... Cassandra is incredibly durable, but you can still accidentally truncate a table or do some massive operation that you weren't intending to do. It happens. That's what backups are there for. Okay, other side, we got Grafana and Prometheus. Grafana is a data visualization tool. It doesn't actually collect metrics itself or do anything like that. It just consumes them and displays them in a nice dashboard. Prometheus is what goes in and actually collects those metrics. So we are going to use Prometheus to collect the metrics from our Cassandra nodes, and then Grafana is going to consume those metrics and display them in a nice, easy to consume dashboard. All right, and of course, Cassandra is the middle of this whole thing, and without it, we would have nothing to show. All right, features list. This is kind of a wall of text, but it covers a lot of what K8ssandra does currently. There's a couple really cool things that I'd like to point out here. Rolling reboots are a thing that are kind of hard to do in Kubernetes by default. That's one of the things that you'd have to configure by yourself if you were trying to bring Cassandra into Kubernetes. You'd have to actually manage that and set that up.
Sorry, Eric. I just have to say, you see, we have some novices as well, not so familiar with Kubernetes. So my work as a developer advocate to protect them too. And just a word about the rolling reboot. Normally, if you do just reboot, then it means what you are going to reboot all your nodes, and then what you have downtime, because all replica nodes are going to be restarted at once, and that's obviously not what you want to have. Again, with Cassandra, you may have zero downtime. So rolling reboot means when you have to apply some changes or do some maintenance works, you still have to restart the nodes, but you can do it one by one, restarting the second one only when first one has finished it already and fully operational. It's called rolling reboot or rolling upgrade, and K8ssandra supports it natively.
Yeah, and that is really key. I think you touched on the magic word there, no downtime, right? You do not want downtime. Cassandra is able to run indefinitely without downtime. If you're geolocated across the globe, across providers, you can pretty much guarantee 100% uptime if you construct it for that. And K8ssandra takes advantage of that. It respects that, and it allows you to actually implement that. So that's really, really cool. Okay. Scale up is something that is very, very common in Cassandra. Scale down, we're going to get into. That's actually something that's a little bit harder in Cassandra. We have a whole lab today where we're actually going to scale something up and scale it down. It's going to be really, really awesome. Gets rid of a lot of the complexity there. Automated repairs we talked about. And of course, the metrics and monitoring and all of that is built in to K8ssandra. All right, first exercise. Right off the bat, we're going to get into this. So setting up and monitoring Cassandra, we're going to go to the repo here today. If I can get some links posted in the chats. Here, I'll post some in Discord and in YouTube. There y'all are. Go ahead and click that GitHub link. That is going to be our GitHub for today. The README there on the homepage has everything we are going to run through. It's got step-by-steps. It's got a table of contents. So if you get out of sync, feel free to just go up to the table of contents, go down to the step we're on currently, and that will bring you there. We are going to go into our cloud instances here. So if you don't have one of those, please do request one from Jack Fryer. His email, again, Jack, if you can post in the chats, just let everyone know where to request one of those. I already have one of those up today. We have a list of links here. You'll notice that everything after the first line there says install first. Those are the things we're actually going to fix. So all of those links should be broken. If they are not, then we have a problem. The first link there, however, is an SSH console in your browser. And what that looks like is this. Now, I will actually exit so I can log in with everyone here. Actually, I'm just going to reopen it. That's probably the easiest way to do it. Boom. All right, this is Shell in a Box. This allows you to connect through your web browser via SSH into our cloud instances. So kind of, wow, a little bit meta there. If you wanted to connect over your own SSH, you feel free to copy that URL at the top of your screen. Go into, say, if you're on a Mac or a Linux box, you can just use SSH via the terminal, and the username is going to be the same there. It's documented in our repo here. The username is EC2user, and your password is DataStax.
Mm-hmm.
All right.
Sorry, just a second. If you don't have too much experience with Shell, when you are SSHing to a new node, to set up a custom user, you have to go SSH space EC2-user at, like in the email, at, and then your unique address, workstation something, some numbers, K8ssandra-workshop.datastaxtraining.com.
Yes, that's an excellent point, Alex. Thank you. All right, so we're logged in now. Now the next thing we're going to do, and you'll notice I'm going to follow through line by line pretty much of this repo. That's so you guys can all follow along and so we can all do this together. All right. So first thing we got to do is we got to add our repository. So Helm is already installed on these instances for us. Again, if you're using your own box, follow our instructions. It helps walk you through the Helm install process, but we already have it here on our instances. So go ahead and do the Helm repo add command, and you'll notice we are adding K8ssandra from the K8ssandra.io repo. So going to go ahead and add that, and we get a success message there. Perfect. All right, now we have to do our repo update, and this basically just activates the repo we've just added. So go ahead and do that, and boom, happy helming. Congrats, we got there. All right, next thing we're going to do. Now, this is not a K8ssandra repo. This is Traefik. Traefik is actually a special ingress controller that allows us to basically communicate from the outside world into our cluster. And we're going to do a lot of configuration of it throughout our commands, but essentially, this just allows us to actually talk to what we're working with here today. So we're going to go ahead and we're going to add the repo for Traefik, and we're going to need to do another Helm repo update, activating the Traefik repo as usable for us. So let's go and do that, and again, we get a success. Perfect. All right, so now let's do a Helm install. Let's install our ingress first here. This is going to use the YAML file. You'll notice the Traefik values.yaml. So I'm going to go ahead and I'm going to run that, and this will take it just a moment here, and boom, done. And I'll actually show you guys in the directory here. We have a whole bunch of YAMLs. We have our kind config, which is what our actual provisioning step of this cluster. You don't ever have to use it, but that's what the scripts we used to provision this cluster used to configure it. We have our petclinic.yaml, which we'll get to in a few minutes. We have our readmes, which are basically the instruction sets, and then we have this Traefik values.yaml, and I'm just going to cat that real quick. Traefik values.yaml, and we'll see there's just a couple ports specified. Just a really simple file. It's just basically saying, hey, we're setting up this ingress, set it up with these particular ports right off the bat, and let's go. So nothing too complex there yet. It's just still pretty simple stuff. Next, we're going to go and we're going to install our K8ssandra tools. Now, K8ssandra tools is the first step here towards getting K8ssandra running. What it is basically all the individual components you need to actually set up a K8ssandra cluster. So all of the individual things that are going to be used should be included here. And we'll give that just a moment again to complete. One thing that's actually interesting to note, when these actually complete, you'll notice we have a couple lines here with information. First thing to notice is that revision line. Revision is basically every time you make a change, that will increment. So every time you do what's called a Helm upgrade command, it will increment it by 1. So as we go and scale stuff, I'll point it out to you again there, but that's going to start incrementing for us. We also have the last date that something was deployed, the namespace, which of course today we're using default, and of course the status, which is deployed in this case. All right, so it looks like our Helm install command worked for the Cassandra or K8ssandra tools. Goodness, that is hard to remember to say K8ssandra, not Cassandra.
You know what? I bet at some point we will stop making any differences between them.
I'm sure. We most likely will. Okay, here we're actually installing the cluster. Now, you'll notice we've done the ingress configuration in this command. Again, I'll just say, down the road, this will be done automatically for you in the actual Helm install commands, but today we're not at that point yet, so we just have to kind of do it ourselves and let it run. So I'm going to go ahead and click enter there, and we will give you guys a moment to catch up here as that goes, and I am just going to go into I'm going to watch kubectl so we can watch this come up. So get pods, and let's let that run. And we're going to watch those come up here. Now, it's going to take, 2-3 minutes for those to actually all come online. And you're going to notice that there's some errors that pop up. Don't worry about it. It is currently, again, release candidate stuff. Some of the stuff hasn't been set up to launch in specific orders. So we're actually relying currently on some pod failures. And then they basically redeploy themselves. They're waiting for some of the previous steps to finish.
Yep. Sorry, but that's a perfect time to give some time to our attendees to catch up and follow the steps. So, yeah.
Yeah, absolutely. We're going to wait here for a minute, so definitely get caught up if you can. And, yeah. All right. Let's see, do we have any questions in chat there?
I'll answer it. The main one was, can we go a bit slower, please?
Can go slower. I'm sorry. I'm talking very fast. I realize that. I will work on slowing down. Call me out on it if I don't.
So take a look while we have time to catch up and do the steps. People use it to hurry on during the workshop because as soon as workshop is gone, speakers are not available and training instances are not available and nothing works and workshop is over. Not for us. We are the DataStax developers and we care. So we want this workshop available for you as long as you want for it to be available. So, okay, we cannot run training instances for too long because we are counting all together the workshops from yesterday and today and tomorrow. There are around 1,000 of them. So that's pretty expensive to us. We have to stop them after 24 hours. But in general, we are always here for you, answering the questions at our Discord server and also at the community.datastax.com. So workshop lasts as long as you want it to be running, okay?
Yeah, we had a request to zoom in here. Is that large enough? I just zoomed in a little bit there. Answer in chat there if you can. Hopefully y'all can see it all right.
And I see a question from Prasad. Cut and paste doesn't work in cloud instance. Well,
if you're going to the repo and copying out of our little code blocks there, it should work with just the normal copy paste commands. I've been using, I'm on a Mac, so I've been using Command C and Command V this whole time, but you can also, I believe, right click and copy paste a little more manually that way.
Yeah, so there were some problems I've heard of before. Personally, I recommend you to use a normal terminal or PuTTY, iTerm if you are on Mac, or any other application you prefer to connect, because, well, Bash in a browser, that's only for those who cannot have anything else. But in general, we recommend to use SSH.
Yeah, absolutely. And the only reason I'm using the, the shell in a box here is because I'm trying to make it as close of a thing to what you guys are provided with as possible. Otherwise, I would totally be in the command line myself on my own SSH console. But All right, let's see. A couple other my copy paste wouldn't work either. Option is proceed. Yeah, interesting. I am not sure about the working with Windows. That I've never had a problem with that in the past. I would try the right-click method and see if that works.
Yep.
If not, there is a tool out there called Putty, which will allow you to SSH as well. I highly recommend having that tool if you're on Windows anyway. I think almost every Windows computer I've ever had, I have installed Putty like first or second thing, and that will allow you to actually SSH with the same SSH command there using the URL,
Yep.
and that should work.
Right now, you could focus on what's Eric doing, and then do the same steps on your own after the workshop, using Putty indeed.
Yeah. All right, so we've got some things are completing here. It looks like we've got our nodes are up. We can see the K8ssandra DC1 default is now 2 of 2, which is excellent. We have the schema is now completed, so you'll notice that is the only 0 of 1 on that list under ready. That is just a step that basically goes through and takes the Reaper schema and applies it to the Cassandra once it comes online. So Reaper, which is that repair tool we talked about earlier, is using Cassandra to store its data. So it is actually utilizing the thing it is repairing. Kind of cool. But it does need to install the schema once Cassandra is actually up. All right, let's see. A couple more questions here really quick. Can we run SQL.sh? Yes, there are ways to do it. We're not going to do it here today, but yes, you can. Let's see here. All right. I think we're good to continue. So I am going to go ahead and Control-C out of my kubectl watch there. And let's go over and look at our next step. Now, we are at the point here where we're actually going to go in and start looking at what our monitoring is. So let's go to our links list. You'll notice this first one, or the second line here is for Prometheus. Let's go in there and take a quick look at that. So Prometheus here doesn't actually display anything, nice and pretty for us to look at, but what it will show you is our node, and it shows you the what's being scraped, how often it's being scraped, how long it's taking to scrape that data. Basically just shows us that we are in fact getting metrics and we are in fact healthy. It's a great troubleshooting step if for some reason we weren't getting any data in our Grafana. The second thing we're going to here is Grafana. Now for all of you, the username admin and the password of secret is what you guys will use to log in by default. Now, if you go to dashboards and you go to manage, you will see this default space here. Obviously, in the final release, again, we're on release candidate. In the final release, those will be a little more accessible. They're kind of buried here in the first release. It's something where they are there, but they're just not super upfront. And we can actually see we're collecting metrics already. So we are connected, we are actually getting data, and we're actually able to monitor our Cassandra cluster via Grafana and Prometheus. Pretty cool. I didn't configure any Grafana. I didn't configure any Prometheus. It is basically there for me when I run the commands. And I'm sorry I keep using the word RC. This is basically a beta. Correct term would be a beta. So just correcting myself there. All right, I'm going to go ahead and I'm going to actually leave Grafana open, but I'm going to close Prometheus, and we're going to go back to our GitHub. And that brings us to step 2. Now, before we get to step 2, I'm going to show you just a couple more slides, just like 2 or 3, and then we're going to jump right back into it. All right, so working with data. Having a database is great, but if we can't do anything with that database, it's useless. So what are we going to do today? We're going to run the Pet Clinic app. Now, Cedric, who's one of my advocate counterparts here, he wrote a Spring app called Pet Clinic. It is fully, what's the word I'm looking for? Containerized. Goodness. My brain just blanked there for a moment. It is fully containerized, and we'll actually deploy it with Kubernetes alongside of our K8ssandra. So there, I said just a couple slides. I kept my promise. It was actually 1 slide. Let's get into it. First thing we have to do is we have to retrieve what our Cassandra password is, our user password is, from the secret. Now, K8ssandra sets up a secret for us when it sets up Cassandra. So we're actually going to have to go in and we are going to have to run a command to get that. And you'll notice here, this giant alphanumeric string is our password. Now, normally, I'll actually show you something here. So if we ls in the directory again,
Eric, don't run. That's not a marathon.
Okay. Slowing down again. All right. What I'll show you here is if we look at that petclinic.yaml that we saw earlier, we're going to go ahead and we're going to cat that. So petclinic.yaml. And we'll notice a few things here. First, I'm going to scroll up towards the top. We have this whole Cassandra password field. And right now it's just got gibberish. That's not actually a valid Cassandra password. We're going to have to put our own in there. Now, we aren't going to do it ourselves. We're going to use a sed command to take advantage of the power of Linux and do it. But it's gonna be replaced with that string we just retrieved. Next thing I'm going to show you is right down here at the bottom, we have this ingress section where we're setting up a bunch of ports. Now those ports are going to be applied to our Trafic ingress. So that thing we set up at the beginning so that we could access our Grafana Prometheus is also going to be what allows us to get into our Pet Clinic app. And that's both for the back end and the front end of that application. So let's go ahead here, and I'm going to copy the sed command, and I am going to paste it here. And now if I cat that file again, so cat petclinic.yaml, and let's scroll up, and there we go. Voila. We have our password in there now. So our app should be able to connect to our Cassandra instance. All right. Now we're going to go ahead and do kind of the moment of truth step, and we're going to apply our petclinic.yaml. And what that's going to do, I'll actually show you kubectl here. So kubectl actually let me watch on this so we can watch it come up. Watch kubectl get pods. And what's going to happen here is you notice we have these container creating on Pet Clinic front end, Pet Clinic back end, and they're really, really fast. Boom, they're up. I almost missed it. I was so slow typing that command. Those pods that just popped up are our application. That is the Pet Clinic application. And if I were to go back to my links list and I were to click on the Pet Clinic demo app, we will see it will load up here. Now, I'll show you one more thing before we actually interact with this because it's kind of interesting. That ingress we've been working with is also on your links list, and it actually has a web UI that you can go in, and next to services, I'm just going to click explore, and I can actually see what's set up as ingresses. We've got our Grafana here, we've got Prometheus, we've got our Reaper, and we've got our Pet Clinic, all right there in this list, and we can just go look at them and see what's configured. Kind of an interesting troubleshooting tool, not really super relevant to us here today, but it's just pretty cool. All right, closing that out and going back to our Pet Clinic. So now that we have an app connected, let's actually work with some data. First thing we're going to do, we're going to go to pet types, and we're going to look at the different pet types that are configured. Now, these are stored in Cassandra currently. We have dog, bird, hamster, all of that. Those are actually in a Cassandra table. And instead of having to go in and type an actual, statement to delete or modify or update, I am going to just click delete here. And just to prove I'm not, kind of doing some hand waviness and that something actually deleted from the database, I'm going to refresh my page just to show you guys that, yes, it is indeed gone. This isn't something that's cached on the web and I can just delete and it looks cool. I actually deleted something from my database. Now, if I wanted to add something, what should we add? Let's add, we have snake. Let's add, we have cat. Goodness, we've added most things. Let's add bird right back in then. So let's add bird. Go ahead and save. And we have bird back in the list. Now, again, I will refresh my page just to kind of prove that this is in fact happening. And notice it sorted it. Now, the reason it did that is we were using clustering columns, which are a way to order your data inside Cassandra. They're a way to order and provide uniqueness. But in this case, the important part is that they're ordering it so that when we refresh the page, it reordered and boom, that's what we had. All right. So we have now removed and added data to our Cassandra through an app just by copying over a single password, the user access password. And this is all done through the driver. This is actually the under the hood. This is the Spring stuff, which all runs on the Java driver. All right. Going back here, I think that is all for this section. Let me just verify that really quick so I'm not getting ahead of myself. Yes, okay, perfect. So next section, we are going to move on here. Now, this is the cool part. This is the part that just makes me so excited. I'll try to talk slow because I get excited here. You can probably tell I get excited about this stuff because of just how energized it makes me. But, okay, in Cassandra, it's very easy to scale up a cluster. It's a lot harder to scale down a cluster, but it is possible. There are ways to do it, but it requires a lot of cleanup steps. There's a lot of rebalancing stuff that actually happens, and it is kind of a job to do. It is possible, but it's a job. There are two ways in K8ssandra that we can accomplish these steps. Now, the first one is through config files. We could actually go in and we could edit some YAML, and we could resize things, and then we could let Helm take care of the rest. Kubernetes and Helm take care of the rest. Or we can just do it with a Helm upgrade command. And that's what we're going to do today. Is we're going to use Helm upgrade to go through and handle all of those operations that we need to do automatically for us. All right. So going back to the exercises, it's now section 3. If you're trailing along, feel free to, or following along, feel free to go down to section 3, and we'll get started here. First thing I'm actually going to do, I'm going to do a Helm get manifest. Now I better exit out of my kubectl. Helm get manifest basically shows me what is currently running in my cluster. Now you'll notice, let's go ahead and Control-C out of this because that's going to go on for a while. You'll notice up there, I had a bunch of YAML files. And they're for all sorts of things. We've got a cast-dc YAML, we've got a deployment YAML. All of these things are basically where the magic is happening that is allowing us to deploy these things without needing to set them all up ourselves. So all of these YAMLs are kind of, they are what make K8ssandra, is all this pre-configured stuff. Now, interestingly enough, I mentioned Helm is a templating language. Helm allows us to make certain parts of these YAMLs dynamic as we need to. And that's what we're going to be manipulating here, is something that was dynamically configured. So let's go ahead and let's clear. It's hard for me to type and talk at the same time. All right, there we go. So now we're starting fresh with the console there. We're going to go ahead and we're going to try to find the value that we are looking for, which in this case is size. Size is how many nodes we have in our cluster, and you'll see it is configured to 1. If we want to change this, we can go through and we can use the Helm upgrade command. Now you'll notice all of our ingress set flags are in this command. The reason for that is anything we set this way needs to be included in the command, otherwise it gets reset to the default. So we would basically lose all of our ingress from this cluster, and we don't want to do that. So let's go ahead here and let's apply our Helm upgrade command. Oh, did it not copy? I guess it didn't copy. And paste. All right, there we go. So I'm gonna go ahead and hit enter on that. And then you know what I'm gonna do is I am going to grep that size again. Oops, did we not? Helm upgrade requires 2 arguments. Did I miss? I think I didn't copy the whole thing. Helm upgrade, Cassandra. There we go. All right, it applied. And you'll notice my revision is now at 2 actually. So I should have noticed that when I hit enter there. I just was moving a little too fast. That's because I have now made a change, and so it automatically increments that revision number. All right, let's go and retrieve our value. There we go. There we go. You notice we set that to 3 in our command up here. So K8ssandra set size right here. Set size to 3, and that is what basically went and resized our entire cluster. Now, to prove this is actually resizing, I'm going to go into kubectl. Actually, I'm going to watch it again because watching is much more, much better in my opinion. Kubectl get pods. And there we go. We see that we have 2 nodes that are also initializing here. Now, those are going to take a moment, and I don't really want to do anything until they're up. But those nodes are now full Cassandra nodes. They are actually running. And if we were to say go into Grafana here in a moment, which we'll do once they show up, we'll actually see metrics being collected from those nodes as well. Pretty cool. All right, let's give it a moment here and give you guys a moment to catch up as well. Any questions there, Alex?
Yep.
Let's see here.
So not so much. Where do those two nodes start up? Very good question by Kevin. That one we should answer.
Sorry, so the question was what? Where did the nodes start?
Yes, if you would simply do kubectl get pods -ow, I will explain a couple of things.
Yeah, let me do that here.
Mm-hmm.
So kubectl get pods. You said /w?
Get pods -o -o space w. Yeah, like that. Oh my god.
Yeah.
Sorry, that's pretty late for me already. Yes. Looks good. Wait a second. While I'm trying to remember, question, how many data centers are here in this cluster? That's only one single data center cluster, because that's an educational exercise.
There we go.
Yeah, thank you. So good. And can you make it a little bit smaller then, so it will be...
Yes, I can. Let me...
Good. Yeah, thank you, -o white. That's at my place, that's almost 8 p.m. and it was a very long day. Okay, so what thing, and do it again. Yeah, and may you push enter sometimes so it will scroll up a bit.
Oh yeah, let me clear, and then I'll run it
Okay, again. Also works.
There we go.
Yep, perfect. So take a look. There are some things I want to answer. First of all, we run these, that's a Kubernetes cluster, but we have only one machine running that. So you have, every one of you have one machine. When we are going to have multiple workers, we use kind for that. So technically that's all the Kubernetes in a Docker cluster. But even in this case, K8ssandra cares of the data allocation and replica allocation over the cluster. So you see on the left part, K8ssandra DC1 stateful default STS 0, 1, and 2. Could you please highlight them? Stateful
yes,
sets services. Yeah, those three.
Right. Yep.
Yep. So take a look. They allocated on kind worker 2, and kind worker 3, and that's not a coincidence. Every next node, K8ssandra will try to launch on the next available free node, so to spread the nodes over the cluster and to have higher fault tolerance in case one of the Kubernetes workers fails. So we have 3 worker nodes, and therefore we have K8ssandra 3 of them on different Kubernetes worker nodes. That's not a coincidence. That's the intention of K8ssandra. Well then, we have one more question by Prasad Kati. I'm not seeing 2/2 in pod listing. So if you again watch those STS, K8ssandra default, STS 0, 1, and 2, I don't know why the third one has 1 out of 2, but...
it's rolling.
It's rolling. Okay, yeah. So every K8ssandra default STS has 2/2. It means what we have 2 containers in one pod. And one container, as I said before, is Cassandra, and second is a sidecar.
Yes, and you'll notice there that when I reran that command, so I wasn't running watch on that command before. That's why it was static there, just so I could highlight things for Alex. But you'll notice I ran it again, and now that pod is online with 2 of 2. So it is complete.
And that's a great question. When upscale, what are the seed nodes? And that's the lovely thing. Thank you, Nuno, for asking, because from now on you don't care about that, because K8ssandra
Yes.
cares about
Sandra
that.
takes care of it for you. You don't have to worry.
Yeah. All pods would end with STS are Cassandra pods. Well, yes and no. In all pods with STS are stateful sets, and Cassandra uses stateful sets. So in this case, yes, all the nodes with STS in the end are Cassandra nodes. Exactly.
Yeah. All right. I think we're gonna move on
Yes,
here.
yes.
We got about 22 minutes, which should be enough to get through the rest of this.
And we still have a quiz.
Oh, that's right, we do. All right. So since we saw those were online, I'll actually go here to Grafana quick, and we'll notice right down at my node status, we've got 3 nodes. Isn't that cool? We got 3 nodes. So now we're actually gathering data from all 3 nodes, which is just awesome. We didn't have to configure anything again. It handled it all for us. It added them to the metrics and monitoring, and it's done. Simple as that. It was basically a 1 command operation to add 2 more nodes to the entire thing. That's just so cool. All right. Going back to it, we're going to actually size it back down. Now, I said this before, sizing a Cassandra cluster down takes a lot of work. It's possible, it's doable, but it takes a lot of work. Today, we're going to do it with 1 command. And literally, if you notice in my command here, all we're doing is we got set size to 1. That's it. We're just resetting the size to 1. Helm and Kubernetes take care of the rest. Let's go ahead and do that. All right. And boom, revision 3. So we notice that that is now in a new revision, meaning our upgrade command took. And I am going to go ahead and I am going to do our git manifest command just so we can see really quick that that change actually took, and I can prove it here for you. And the size is now set to 1. Now it's going to start spinning those down. We're going to see these nodes here for a while. Those are going to be spinning down. It takes some time. So we might not get to them before the end of the session here to take a look. But those are, in fact, starting to spin down and terminate themselves in a graceful manner that is Cassandra safe. And that is really key. Doing it in a Cassandra safe way is important to not have downtime and not lose data. All right. Running repairs. We're going to get to that in just a moment because we have to talk about what repairs are. So we talked about entropy earlier. Entropy is just, the fact. It's a fact of life. It has to do with physics, right? Things tend to trend towards chaos, and we can't break those rules with our distributed systems. In fact, we tend to notice those problems a lot more in our distributed systems because instead of having a single drive that could fail, we have potentially hundreds or thousands of drives that could fail. We have hundreds or thousands of processors, of different hardware components. We're basically increasing the amount of places where something could end up going wrong. Anything going wrong causes or can cause what's called entropy in a system, which is basically a gradual degradation of the system. In data terms, in Cassandra, that can cause data degradation. And we don't want that to happen. So in order for us to combat entropy, we run repairs. Repairs are a tool to reverse entropy over time. Now, the repairs work by constructing Merkle trees, which are essentially, they take in the simplest form, I'm going to very oversimplify this, but they take a chunk of the data, they hash it, they get the hash value, and they take that same chunk of data over on the other side, they hash it, and then they compare the hashes. If the hashes don't match, then they know that some data is out of sync, and they'll go and find smaller and smaller chunks until they can find what data is out of sync, and then they stream that data across to bring it back into a reconciled state. In the simplest form, that's what a repair is. Now, there are in Cassandra, there's things called incremental repairs. If you've got DataStax Enterprise, there's a thing called node sync. There are a lot of kind of more advanced tools to accomplish the same thing. Today, we're just going to focus on simple repairs. And honestly, in K8ssandra and most Cassandra deployments, simple repairs are really all you need. You can accomplish what you need with simple repairs. The other tools are just there for, operational streamlining and things like that. Okay. Running repairs is done through a UI where we will schedule them, and then we will also be able to trigger them. There's also some information we can glean about our cluster through this UI, and we'll get into that in just a second here, because it is now time for the next exercise. So in your link list, we're going to go down to the line 4, which is Cassandra Repair Reaper. Go ahead and click on that. That's going to bring up our repair console. Now, you'll notice here there's actually our topology is laid out. We've got DC1, which is the name of our data center. We have a single node in DC1, and this node, actually, we can see the IP address. Pretty cool. What we're going to do here is we're going to go click Schedules. And from Schedules, we're going to click Add Schedule. And we're going to go ahead and we're going to start typing in Spring Pet Clinic. And notice it auto-completes. It actually knows what key spaces we have on our cluster. Key space being the bucket that stores tables. That's what our app is interacting with, is the Spring Pet Clinic key space. Okay. Owner, I'm just going to say I'm the owner for now. Obviously, if you're in a big organization or something where you actually want to keep track of things, you should probably be a little more explicit about that. But just for purposes of the demo, we're going to do it this way. Interval in days. Best practice is to run a repair every 7 days. So 7 should be the number you use here unless you have a really good reason not to. It does allow you to configure that. But let's use 7 there for now, and I'm going to hit Add Schedule. And you'll notice my repair is now set up, and we are good to go. Now, if I go back to clusters here, nothing is currently running. But if I wanted to kick off that repair, I could go back to my schedules, and I could click Run Now. And you'll notice it says repair will be run shortly. We'll start shortly. And in a moment here, we'll have to give it a second to actually kick off. But it'll pop up here with a progress bar saying, we're basically repair running. And it'll give us a little progress bar on that. We'll give it a couple seconds here. Let y'all catch up. I got a question here. If the number of nodes is limited to 1, can we still be able to scale up? Limited to 1. I'm not sure what you mean by that. So in Helm, when we ran it, the default was at 1 node. We were starting with a single node, and then we were scaling up from there. So yes, you can scale up by using that set flag, the set size equals and then the number of nodes. I recommend not scaling up, like 1, 2, 3. Scale up probably to actually 3 nodes, because 3 is kind of for Cassandra where you start getting Cassandra-like behavior. You start being able to take advantage of the distributed nature of Cassandra. Actually, best practice, if you're trying to actually run something in production, I would highly recommend starting with 6 nodes in 99% of the use cases out there. Okay. If you look here in our UI, we actually had this repair kickoff. We see the progress bar, and it is actually running. So we just triggered a repair that's now going to run once every 7 days on our cluster, and we don't have to think about it. It just runs, and we can check back if we want to get some information, check on some health statistics, but it just runs. Simple as that. It's when I explain these things in the past, I'd go like 25 minutes of explaining in depth how this stuff works. Now with K8ssandra, it's just like I'm done explaining. This is incredible. I don't have to explain things anymore. They just work. Really, really cool. Okay. At the bottom of the repository, you'll find some resource links. I'm not going to navigate back there again, so I just want to point that out. All right. Last piece of this, backup and restore. Now, I mentioned earlier that Medusa, the backup and restore tool, is part of K8ssandra. It is currently in K8ssandra, and it is most of the way implemented, but it's not something we're going to deal with today because, again, we're in beta, and there are just a couple things that are still being ironed out with it, and we just wanted to give you guys a good experience as opposed to trying to fight something that is still kind of being hashed out. So the actual implementation, if you want to go and try to run this yourself, you can run a helm install command, and essentially what you're doing is you're installing just a quick running job, which will go and create a backup. We use the set flags to configure what that backup will be called. We also use set flags to configure where that will be. So it can be on Google storage, S3 storage, local storage, any of those things. We can actually send our backups there. And I believe we're expanding that as well on the roadmap. I believe the intention is to get a lot more storage providers in there as well. Okay. With that, we are not going to do exercise 5 because of the reasons I just mentioned. We're going to get into resources. A couple things here. K8ssandra.io is the webpage for the open source project. Highly recommend you go check it out. A lot of good stuff there. There are links to the GitHub, to the docs, to basically everything you need to get involved with the project or to use the project. Then also the project GitHub is github.com, K8ssandra. Highly recommend you check it out. There's a lot of work that's been going on there. You'll notice John Sanda in both of the chats. He's one of the engineers who's actually been committing large portions of the code to this project. He was nice enough to come on and help support questions today in our chats. So thank you, John, for doing that. But he and many others are there actually contributing to this project. Okay, roadmap. This is always the exciting stuff, right? What's coming? What's next? As with any open source project, this is determined partly by the users and community around it. So if there are certain things on here that are very high priority, let your voice be heard, get involved, and actually help to prioritize the lists here. But there's a lot here. I mean, goodness, upgrading your clusters, some node lifecycle stuff, data loading, that's kind of a big one. There's Spark connector, Kafka connector. All of those things are on the roadmap, and we are actually working actively to get them into the project. So definitely get involved. If you have opinions on these things, let your voice be heard. Okay. Learning. Now, this is where we talked about the certifications before. Go to datastax.com /dev. You can get links to the Academy courses. There's also a whole bunch of curated content on Katacoda. If you haven't used Katacoda yet, it's basically O'Reilly released a really cool tool to do full scenarios in terminal in your web browser. So kind of a self-service lab that you can do from your browser with virtual machines and everything all there for you. So a lot of scenarios there with different exercises. We also have community.datastax.com, which is basically our Stack Overflow managed by DataStax. We talk about all things Cassandra there. It's a really good place to hang out, interact with open source, interact with DSE, interact with K8ssandra, whatever it is you have questions on, bring them there. Tons of people are on there all the time answering questions. So please come on by. We have social media. DataStax Devs is, of course, we are all employed by DataStax, but we are here to, as Alex said, upgrade developers. Our goal is not to be marketing. We are not trying to do anything like that. We are trying to provide developers with useful stuff that will help them to, as Alex said, improve their career and get paid more. So,
well.
Manage our social media.
Yes and no. You see, I'm happy when people are getting paid better for the job they're doing, but that's not my main purpose, I would say. I'm working in the IT infrastructure and IT field for a way too long time, and I'm tired of so many people doing architectural mistakes and doing some software development not as good as they could. So I'm happy to make the community better and make people developing better software. That's my main point for me.
Yes, I would agree with that as well. All right. Let's go on. Now, this is the cool part. We're announcing a Cassandra Kubernetes certification. Now, we already have two certifications. We have our developer and our administrator certifications. But we are working on, very soon, it will be popping up, so keep an eye out for it, the Cassandra on Kubernetes certification. And it's going to cover a whole lot of really deep content on that topic. So highly recommend, keep an eye out for it. It will be coming very shortly. All right, and I will bring this up as well. If you do want to see any information on certifications, datastax.com/dev/certifications will get you to basically the page that has all of that information. All right. I will bring up here, we do have our Academy courses, the DS201, DS210, and DS220, which most everyone who's been in the Cassandra world for any length of time has probably heard of or taken those. Those are basically fundamentals courses when it comes to working with Cassandra. Those are all offered at the /dev/academy URL there. I highly recommend you check them out if you have any interest in pursuing Cassandra in pretty much any capacity. But they are very, very useful courses. And there's a lot more courses there as well.
Yep, and I would say we give you the chance to pass the certification exam for free. But if you are not ready, that's just a wasting of time. Not money, but time at least, definitely. And time is very valuable. So first get the course, it's free, then pass your certification exam, and you have your very well-deserved certification. That's how it works.
Yeah, absolutely. We also have a book that is Cassandra the Definitive Guide, and it really is the definitive guide. This was written by Jeff Carpenter. He is one of my coworkers here at DataStax. He actually was working, I think, on was it the second edition of this book as well? So he's been writing this book for a while and updating this book fairly consistently. It covers all sorts of things from the reasons why Cassandra works the way it does to how to make it do things. It's a very, very informative book. Highly recommend you check it out if you have any interest at all.
If you want to attend our next workshop, subscribe at bit.ly/subscribe-datastaxdevs, and you will be with us with our next events, because we run Cassandra Global Meetup program, we run DataStax Monday Learning program, we have Cassandra workshops every week, and we always have even something more for you. So subscribe at bit.ly/subscribe-datastaxdevs. And now open question. What do you like the most? And what should we improve? Now you can type everything you think about us.
More swag. The resources made available. They actually are going to be available in the GitHub that you guys all used for the labs today. There are links down at the bottom for everything we've talked about pretty much. So the resources should all be there. What should we improve? Your presentation skills. Is that what you'd like, or what we should improve?
Yeah, that was my next question. Slow down. I didn't have time to highlight that, but yes, maybe we have to slow down a little bit indeed. But you know what? Again, first you can watch what Eric is doing and then do it on your own, and we are staying with you. So don't worry. More time to handle the tools. They are cool. Absolutely. But the training instances stay with you for 24 hours. So you definitely have time to handle the tools. That's no worries.
Yeah. There was another one on Helm there. Yeah. On the left-hand side at the very bottom.
Which one? This one?
Oh, yes.
Uh-huh.
Practical documentation resources, K8ssandra Helm. So Helm actually has all their own documentation, which is very available on Google. But K8ssandra, we actually have the documentation was all in the links we provided in the k8ssandra.io. Highly recommend you check that out. And of course, Cassandra documentation, datastax.com. Is it /docs or is it docs.datastax.com currently? I don't remember the URL for that off the top of my head. But we do have a doc site, which we can get the links to as well, which is very in-depth on a number of Cassandra topics.
Yep. And I'm completely agree. This one I wanted to highlight why and how clients are using Cassandra. In general, Cassandra is the best fit when you are going to work with some big size data over the world, and your SLA requires to be highest possible availability and highest possible performance. And for any kind, for every situation like that, Cassandra is a good fit, and that's why companies like Apple, Netflix, Instagram are using Cassandra too much.
Yeah, actually, if you pull out your phone and you just look at the apps on your phone, pretty much, I'd say 80% plus of the apps on your phone probably have Cassandra somewhere in the stack. It's incredibly widely used by modern applications. The times you don't see it used so often is if someone's got a very legacy application that hasn't been modernized. Oftentimes, maybe Cassandra didn't exist at that time, but for most modern applications, Cassandra is somewhere in the stack.
Okay. So I think we are done for today. Thank you for feedback. We cannot answer every feedback right now, but we read them after the workshops and we react on them. Good. Too many topics in one presentation. I would like to get more out of deeper dive into K8ssandra and less on Cassandra Kubernetes. I agree, and we will do that. So this workshop is more beginner to intermediate level, and next one we will do K8ssandra is one of our favorite topics from now on, so we will do a much deeper dive with requirements to attendees to have already some knowledge in Kubernetes and Cassandra, so we can focus on K8ssandra. But you know what? That's a day 0 for K8ssandra. K8ssandra was just released, and you already want to have a full-size deep dive workshop on that. It takes some time to prepare. The workshop we did today, it took many dozens, I don't know, maybe hundreds of working hours. So we just have some time to prepare. We will do that. But thank you for your opinion. We really value that. Is this recorded? Can we watch this demo later? Absolutely. Same link.
Yep. That'll be on YouTube. It doesn't go away. It's on the YouTube channel for as long as YouTube lets us keep it here.
Okay. Cassandra is good in OLAP. Nope, it isn't. Cassandra is an OLTP database. But if you want to have a full-fledged OLAP over Cassandra, it's absolutely possible. For example, with Apache Spark. Spark is very well integrated with Apache Cassandra, so you may have whatever Spark suggests to you. Machine learning over Cassandra's data. Very easy. Even SQL, Spark SQL, you can run structured query languages with foreign keys over Cassandra with Apache Spark. It will not be as lightning fast as Cassandra is, but it will work. So for OLAP, prefer Cassandra plus Spark. And I think we are over time, so it's time for us to stop. So I want to say a big thank you to everyone who participated in this workshop. We love you. We are very happy you were with us. Whew.
Awesome.
Thank you, Eric. So
yeah, route?
I think not yet, but we are going to be out in a moment. So see you next time.